Version 3, question 3, looking at fractions of the moon. We've got T as the number of days after the 1st of January. We've got F is the fraction of the moon that's visible. So first off, what days in January would she expect it to be in the 3rd quarter? So the 3rd quarter is going to be when F equals 0.75, and we can substitute that into our equation, and we end up with 0.75 equals 0.5 cos 360 over 29 t plus a half. So on our calculator, if we delete that, and we end up with 0.5 cos brackets fraction. We have to use x rather than t on a calculator, but that's just because it's always the same variable. And if we draw that, need to make sure that it's a sensible view window. So if we take it up to 32, and if we take that up to 2, then it will look a bit more sensible. So what we're after is when F is 75, so we can do gsolve xcal when that is 75, and that is 4.83. So that will be on the 5th of January. It says days, plural, which means it's not just that one. We also need to worry about the one that's over here. And that is on 24.2. So it's the 5th of January and the 25th as well. Okay, how much of the moon is illuminated on New Year's Eve? So, New Year's Eve is going to be the 31st of December. That is the day before the 1st of January. So what we are looking at is when t equals -1. Now, on your graph, that means you should be able, if we come out of that for a second, if you move your graph one space that way, you should then be able to find it. So we can do gsolve ycal x is -1, and it comes up as 0.988. So we've got F, we need to show that we've substituted it in. Over 29 minus 1 plus a half. So F equals 0.988. Okay, so part C, on what day is there a new moon? A new moon is when there is none of the moon visible. So that's when F equals 0. So C, F equals 0, gsolve root. So when F equals 0, x equals 14.5. So t is 14.5, and that is the 15th of January. Because this calculator is set up to show the differential as well, it also shows you the gradient at the point you've chosen. That's useful from the point of view that it gives you an idea as to whether or not the gradient you've worked out is correct, but you can't use it straight off as a number. Okay, D. The period of the lunar cycle. So the period is 360 divided by this. So the period is 29 days. The actual lunar period for our moon is 29.5. So in reality, they're likely to use somewhere between 29 and 30. Okay, so E. It has been noticed there are werewolf attacks at the full moon. So a full moon is when you've got the whole of the moon visible. So that's when F equals 1. So what day are we going to need that? So if we substitute that into our equation, because realistically we always need to substitute it in, 360 over 29 t plus a half. Then on our calculator we can ask it for GSolve, no, not that, GSolve xcal when y is 1, and that is when t is 0, so the 1st of January. Now, this is a bit sneaky because January has more than 29 days, so it's going to appear again. So GSolve, it happens to be the maximum when it's a full moon, so it also happens when t is the 29th, which is the 30th of January. It's normal on a question like that, if they're going to give you 2 dates, for them to write days rather than day. So F1 and 2, complete and put the graph for January. So you've already got your equation in there. So if you come out of graph and go into table, your equation's already in there. Just make sure that you set it up. It's what you need. So 0 to 30 going up in 5s. So because this one's set up to show the differential, this last column here tells you what the gradient is at any point. So our y values, it starts at 1, we've then got 0.74, 0.219, 0.003, 0.315, 0.824, and 0.988. Okay, for part 2, it asks us what the gradient is on the 5th of January. So from looking at your calculator, you are expecting it to be about this. Because it's in degrees, you can't actually differentiate it to find out, so you're going to have to draw a tangent on at that point and work it through, but this does at least give you a fairly safe indication as to what you're expecting. So if we plot that graph, that should look like that. The gradient on the 5th of January. So find the 5th of January. Draw a tangent on. So the 5th of January, you need to be a little bit careful because the 5th of January is at 04. So that we're looking at a gradient of about there. So if we draw our tangent on, we can then work out gradient. So exactly the same way as we did on some of the slightly harder questions earlier, we are expecting something around 0.08-ish. Okay, so lastly, we are looking at the transformations to move this to here. So first off, this bit here is your translation. It's an adding thing, so it moves it up or across. So we have a translation of 0 because there's nothing added or taken away in the bracket, and a half. We've then got two other things left. We've got this bit here, and that happens in the x direction. So as it's written, it's this times by x or times by t. So because it works the opposite way round, it's 1 over that, or you flip the fraction. So we've got a stretch parallel to the x-axis or the t-axis, scale factor 29 over 360, and then we've got this bit out at the front, which is being multiplied. So that's a stretch parallel to the y-axis, scale factor of 1/2, or scale factor 0.5.